Physics exam. Number 1. Which of the following best describes the graphic above? A. The forces are balanced and the woman is moving forward with a net force of 15 newtons. B. The forces are unbalanced and the woman is moving forward with a net force of 25 newtons. Or C. The forces are unbalanced and the woman is moving forward with a net force of 15 newtons. Number 2. Which of the following best describes why the ball sits without moving on the table? A. The forces acting on the ball are unbalanced. B. The forces acting on the ball are balanced. C. There are no forces acting on the ball. Number 3. Use the graphic of a roller coaster below to answer the questions that follow. Number 3. Between which 2 points is the greatest increase in potential energy? Between J and K? Between H and I? Between I and J? Number 4. At what point on the roller coaster is the kinetic energy the greatest? L, B, J, C, K. Number 5. A car is traveling north at 50 kilometers per hour. What is the situation describing? A. Speed. B. Velocity. C. Acceleration. Number 6. The car in the diagram is moving forward down the road. Which law best explains the movement of the driver as she applies the brakes? A. Law of inertia. B. Law of F equals ma. C. The law of action-reaction. Which of the following represented a skateboard that is not in motion? A. Graphic A. B. Graphic B. C. Graphic C. The graph below describes the motion of a motorcyclist through an obstacle course. Use the graph to answer the questions that follow. Number 8. Between which 2 points do the motorcyclists have the greatest constant speed? A. Between O and A. B. Between B and C. Or C. Between A and B. Number 9. The boy is bouncing on the trampoline. Which law best applies to this situation? A. Newton's first law of motion, law of inertia. B. Newton's second law of motion, force equals mass times acceleration. Or C. Newton's third law of motion, action-reaction. The graph below represents the distance and time of 3 runners in a race. What was the average speed of runner B? A. 1,000 meters per second. B. 2.5 meters per second, or C. 0.4 meters per second. Use the graphic below to answer the following question. The students were trying to move 2 rocks across the table. Which of Newton's law best describes what they are doing? A. Newton's first law of motion, law of inertia. B. Newton's second law of motion, force equals mass times acceleration. Or C. Newton's third law of motion, action-reaction. Use the graphic above for the 2 questions that follow. Which of the cylinders, number 12, which of the cylinders above is showing balanced forces? B. Cylinder B. C. Cylinder C. Or D. Cylinder D. Number 13. Which cylinder will move to the left with the greatest net force? A. Cylinder A. B. Cylinder B. Or C. Cylinder C. Number 14. Which of the following would be an example of Newton's law of inertia? A. Jumping up and down on the ground. B. Launching a rocket into space. C. Sitting in the back seat of a car moving 60 miles per hour and watching your phone fly off the back seat as your mother hits the brakes? Number 15. At a circus, a human cannonball with a mass of 70 kilograms is shot out of a cannon with a force of 1,400 newtons. What is the acceleration of the human cannonball? Record the bubble in your answer on the grid. Number 16. Which of the following would be a good example of Newton's law of force and acceleration? A. Racing paper airplanes out of a thick construction paper and thick notebook paper using the same amount of force on both. B. Hitting a baseball with a baseball bat. C. Suddenly leaning on the wall. So number 16, which would be a good example of Newton's law of force and acceleration? Racing paper airplanes out of thick construction paper and thick notebook paper. B. Hitting a baseball. Or C. Leaning on the wall. Number 17. A golfer hits a golf ball with a club. The mass of the ball is 0.05 kilograms. The ball accelerates at 2,000 meters per second squared. What is the force that accelerates the ball? A. 1,000 newtons. B. 100 newtons. C. 40,000 newtons. Number 18. The photograph shows a rocket carrying a space shuttle off the launch pad. How can Newton's third law of action-reaction be applied to explain the movement of the rocket? A. As the fuel burns, gases push against the rocket and the ground, moving it upward. B. As the fuel burns, gases move out of the rocket and reduce air resistance. C. As the fuel burns, the mass of the rocket decreases. Number 19. Sarah was hungry, so she decided to make a pizza in the oven. What energy transformations occurred from when she turned the oven on to when she ate the pizza? A. Chemical to electrical to thermal. B. Electrical to thermal to chemical. Or C. Thermal to electrical to chemical. Number 20. During a demonstration of Newton's law of motion, a student used the setup shown in Figure 1. The student flicked the index card with a fingertip and the coin fell straight down into the plastic cup as shown in Figure 2. Which of these best explains why the coin fell straight down into the cup instead of remaining on the index card? A. The coin was at rest until the card was removed, so it tended to remain in the same location. Once the card was gone, the unbalanced force of gravity caused the coin to fall. B. Moving the card applied an action force on the coin. Since the card was gone, gravity applied a reaction force on the coin. Number C. The card had less mass than the coin, so a smaller force of gravity acted on the card. The larger force of gravity on the coin made it fall. Make sure you have all your answers recorded on your answer document and turn it in.